Okay, so much for namespaces. And one more technical detail is the serialization format for RDF. So unfortunately, it's not like there is a single format, something like .xml, .txt, that is used for RDF data. Instead, there is a whole bunch of different formats. So there is one called RDF XML, which, as you can guess, is an XML representation of RDF data. And in that case, it would have an XML extension. That's something that's not that used that often anymore. It's something that was used especially in the beginnings of RDF, because RDF back then was new, 20 years ago, but everybody already had XML libraries for data exchange. So all these existing systems that were able to deal with XML were able to at least read in RDF data if it was written in RDF XML format. Nowadays, this format isn't so important anymore. There is a format called RDFA, which is used for embedding RDF data into web pages. We'll look at an example for this a bit later on. There is a format that is used for streaming RDF data, or when you want to create a dump of a data set. So you want to have a whole data set as a download or as an upload. Then typically you use the format called N-triples or N3. When you do development and want to have a file that you edit manually just for development and testing purposes, there is a format that's made especially to be human readable, and that's called Turtle, which I'll show you in a minute. And then again, there is another format typically used for web applications, JSON LD. Many client-side web tools work with JSON data, so there is a way to encode RDF in JSON as well. So these are the major formats, and then there are some additional extensions and variations. In practice, you don't have to worry too much about it, because first you're going to work with a number of libraries, and these libraries are able to read in one format and write out in a different format. So they will deal with all the conversion issues if you have to convert RDF in a specific use case. And in practice, you would choose the format specific to the application that you have. Now, if you want to create a dump of a data set for backup, transforming, or uploading somewhere, you would use N-triples. If you're writing something for development, typically you would use Turtle. So in most cases, after you have a bit of experience, it's clear which format you want to use. What we used so far, most of the time, is the format called N-triples. And N-triples is simply a full triple subject, property, object, all written on one line. So here, this is a new line character, just because I couldn't fit it on one line. But in a file, each triple has to be on one line, not split on two lines and not two triples on one line. And to show that the triple is ending, you have this period here. And as an additional restriction in this N-triples format, you cannot have any namespace declarations. So each triple must be the full URL for subject and property, and object can optionally be a string, as discussed earlier. So that's the N-triple format. As I mentioned, this format is good for streaming, for example. If you have a namespace, it's a bit difficult with streaming because you must know the namespace declaration. And if you start reading it in the middle of the stream and you see a namespace, and the namespace was defined in the beginning of the stream, then you don't know the namespace and you cannot process it. So in N-triples, you can read each line independent of the others. So this is the reason namespace prefixes are not allowed there. Let's look at the Turtle format. This is the one that's used mostly for development purposes when you need a file that's readable by humans. So first, you can see that we can have these prefix declarations that I mentioned earlier. So to make the whole file more readable, instead of writing out full URLs like for FOV, the XSD, the data type descriptions, we just define the prefix up here. And we can also define a base URL. So for everything that we want to use without the prefix name, we can optionally define the space URL. So now in here, we have the triples, and you can see in the turtle format, we can have for one subject multiple properties and objects. For example, Bob knows Alice. Bob has a birth date of the date here. So we have one triple, two triples, three triples, four triples. All of them have Bob as the subject, but we don't have to repeat Bob all the time. Using the semicolon here, we indicate that all of these predicates and objects belong to the same subject. And then at the end, we have a period to show that we are finished with this subject here. Similarly, we have this entity here, WD, is the Wikidata knowledge graph. We are looking at the entity Q12418. And by now you remember Q12418. This is the Mona Lisa. So we have the additional information about the title and the creator as before. And the last thing was about this movie. So the movie comes from another knowledge graph here. It has another long ID. And the subject of the movie is Q12418, which is the Mona Lisa. So if you translate this turtle file into a graph, it looks like this. So it's the same graph that you've seen before, but now it's a proper RDF graph. So we have everything here is a URI. Alice is a URI. Bob is a URI. The predicates in between them are URIs here with a namespace prefix. And we have a data type. And again, remember, this is not a string, it's a date. So you cannot omit the data type declaration. Like I explained earlier, you have to say this is of type XSD date. So starting next week in the lab, we'll work with Python and RDF. So there are a number of different libraries. We're going to use one called RDFlib. And then you'll see how you make these graphs in RDF. But briefly, there are library functions for creating a graph, for reading RDF data from a file, and then for modifying, traversing the graph, and doing various other graph operations. So here in the course, we mostly work with Python, but there are tools for RDF in most programming languages like Java and so on. So in RDFlib, you'll see it's all very straightforward, like most things in Python. So you create a graph, a knowledge graph, using a function from the library. You can read RDF files in different formats, like here, the file would be an RDF XML. We can create a new subject in the graph, or we can look up a subject in the graph. In this case, we are looking up a subject with a URI. And then, for example, we can traverse the graph. In this case, we are traversing subject, properties, and object from the graph. And then you can do something. You do some processing, for example. So the first exercises will happen in the lab for this lecture. All right, you made it. You have the first basics for working with knowledge graphs. You understand RDF. And in the next part, I will talk a bit more about the big picture. We looked at lots of technical details, but in the next example, I'll show again how you can make use of knowledge graphs, in this case with a data integration example. See you then.